So this is chapter 5, section 3, number 27. So they want us to find this definite integral. And we have to do it using geometry. So what you should have learned that this definite integral is the net area. And you need to know the difference between net area and area because they're different. And we'll probably do a problem that will deal with it. So you need to know what this graph looks like. So once upon a time, you had this class called pre-calculus. And in pre-calculus, one of the first things you learned was families of graphs and transformations. So you learned absolute value of x looks like this. That's absolute value of x. And then the next thing you learned is what a minus sign does. If you have a negative in front of a function, it flips it over the x-axis. So this graph's going to look like this. A reflection over the x-axis. That's the graph of minus absolute value of x. So that's the one we're going to do. And we are going to go from -1 to 2. And we're going to find the net area to evaluate this integral. Okay, so let me draw more stuff. So it's going to be there to there. And I'm going to shade this. So it's that area and this area, but it's net area. So anything below the x-axis, you subtract. Now it's important to realize areas are never negative. That's why they had to define this new thing called net area, where you could actually get negative. So let's look at the sides of this. This is 1 and that's 1, because this is a line with a slope of 1, y equals x. So it's a line with a slope of 1, so if I move over 1, I go down 1. This is 2, but if I go over 2, I go down 2 because it's a slope of 1. So I know this side is 2. So I have two triangles. So this integral will be the area of the first section, but it's negative because it's below the x-axis. And the area of a triangle is 1/2 base times height. And then, since this is below the x-axis also, I'm going to subtract again. And the area of that triangle is 1/2 base times height. And so this first one's going to be -1/2 minus, this one's going to be 2. So the answer is -2 1/2, which is -5/2. So that is the value of this definite integral. That is number 27. Let me see if they ask more questions on that. Use geometry. That's what we did. Sketch the graph and show the region and interpret your results. So we've done all that. We did it.